remember I also had some insight
Yeah.
that we were talking about. I was listening a Casper session about square roots. So
Okay.
trying to remember what.
I started the recording. I'm hoping, but we have the governance meeting starting in 5 minutes here.
Oh, in 5 minutes. All right. Let's see here. I'll show my screen.
This will be short recording. That's nice.
Yeah. Yeah. So okay. It was, yeah. This is. Oh wait, not this slide. This is a good slide to look at. So when we're trying to take the square root of this race condition, right? The insight was kind of like we had to add this coordination process in parallel to make sure that the same message is fed to like both of these square root instances of the like receive process. And what I didn't realize when we were talking about it before is, well, hey, we have a receive process here and we have two sends. So like there should be a com happening. Like there's still a race condition here, except for the fact that we have like this superscript L and the superscript R on these channels. So what he was saying is there's some way of, basically like taking this channel that we have, this square root X, like whatever that meaning is, we can define it through like structural induction, I think on the previous page or maybe two slides before. And then, but this square root X with an L superscript is like taking that name square root of X and then making it different somehow by using some map. I forget exactly what he was saying, but you can have like, different subsets of like your names designated to kind of like, take these like, well, you have this map that you're calling. Yeah, exactly. I mean, yeah, so it's just like a label essentially. But that is now preventing a COM event from happening on this level, right? Because now we've put this extra label on this square root and this square root of X. So no COM event can happen here. That's not even possible because necessarily this, with the superscript L and superscript R, it's different than without a superscript at all. But then when we start, like consuming those messages, of course, we're going to consume them on the superscript channels. And then once we've consumed both of those messages and, have moved into this second receive, now we're just dealing with the regular square root of X channels again. So I had totally looked over this, these superscripts as being important, but they're absolutely essential because we would have COM events happening on this level, which is something that we absolutely don't want to happen because we can't enforce a coordination if that's the case.
Yeah, I see that.
Yeah.
So we create this C from this input that we already have, right?
Yeah, exactly. Yeah, so this coordination process is somehow related to everything that's under this square root to begin with. Well, I guess really it's mostly just related to these two send processes, but it's all related anyways. Yeah, and something else that he said that I'm not sure I understand why exactly it's important, but this out, oh well, I guess maybe this is why it's important. This out channel that he's defining here, he made a claim about how we can show that this out channel is actually fresh, with respect to like all of these other channels that are appearing here. So that we, again, don't have like any possibility for a COM event that happens. Like other than the ones that we want to prescribe to happen.
I just realized that Dan's example for select with matching is exactly the same, right? You create another thing on which you send something and then you have a select.
Yeah, that's what he was saying during the podcast, is like this join somehow is intimately related with like the choice or select is what we're calling it, you know. Yeah, somehow there's like a correspondence between these two constructs.
And I can see how can you transform this from square root to n root, but I don't see how can you just easily create n joins.
Yeah.
Well, and the list, right?
My question, and I'm still not entirely sure how it works out, is like, okay, we did this for a race condition that very specifically had 1 receive and 2 sends. What if that race condition is 1 receive and 3 sends? You know, what if it's 3 receives and 1 send? You know, I mean, like there are different race conditions that we have to talk about. And he claimed that it's more or less straightforward how you like taking this as an example and going to like these other situations. So, I don't see how it's possible. So I don't know.
Yeah, must find the time to try something.
Okay.
yeah, right.
And he said, sorry.
Yep. Well, our time is up. Do you have any final?
Yeah, I just wanted to say that this out. Greg mentioned that this last out must be garbage collected somehow. So yeah, we were talking about this. Yeah, this is definitely like left in the air.
Yeah.
And I wanted to introduce myself to Isaac. Isaac, I heard a lot about you, including this square root conversation that Greg was talking about. Maybe we should either in one of the rholang sessions or somewhere else, we should do a, I guess, brainstorm session about top-down formal verification of the different components of the R-chain stack. You know, there's TLA plus. Yeah. I think Powell did some little test of that in some portion of it.
Yeah.
Then there's Alloy Tools, apparently, is another thing that works in the data side of things. Okay. So I wanted to pick your brains on, can we do some degree of top-down verification to identify bugs? I mean, we are doing some bottom-up testing right now.
I'm going to restart